Alright, so today we're going to be looking at how to find the unit vector given a vector. We have a couple of examples. We're going to be starting with example 1. We'll go ahead and get right into it. Now to find the unit vector, we're going to do one thing, and we're just going to grab our x and our y, and then we're going to find the magnitude of that. So we're going to find the vector magnitude, and that's going to be by taking the square root, getting our x value, -4, squaring that guy, and then adding it to our 5 and squaring that as well. We'll go ahead and do that. Sorry about that. There we go. So we'll go ahead and do that. And sorry, my square root doesn't look the best, but you get the idea. So now when we do this, we get v equals the square root of 16 plus 25. And then 16 plus 25, that is going to give us our 41. So that means v equals the square root of 41. So now when we want to find the unit vector, what we're going to do is our unit vector will just be our -4 over the square root of 41. And if we want to rationalize, we can. So if we rationalize that, it's going to be -4 square root 41 over 41, sorry about that. And then comma, it's going to be 5 square root 41 over 41. And that is going to be our unit vector. So originally, before we rationalized the denominator, our unit vector would have been -4 over square root 41, comma 5 square root 41. Now, I apologize, I moved my paper a little bit, so we're going to try and get a better example, one that you'll see more likely, and hopefully it'll be easier to witness. So for this problem right here, we're going to go ahead and grab both of these guys, and we're going to square root them. And that's going to be 3 square root 2 squared plus 16 squared. That's going to give us 9 times 4 square root plus 256. 9 times 4 is going to be 36. Alright, 36 plus 256 is going to be 292. I'm going to try and get the biggest square root possible here, and it looks like it's going to be 4. So it's going to be 2 square root 73. That's going to be our vector here. So now we're going to go ahead and rewrite these guys for our unit vector. And we're going to rewrite it as 3 square root 2 divided by 2 square root 73, comma 16 over 2 square root 73. Obviously, if we need to reduce, we will. So for example, let's go reduce and we're going to rationalize. For now, I'm going to just reduce this. I'm not going to rationalize, just save some time, because I think you guys get the idea. But I'm going to just reduce and get 3 square root 2 over 2 square root 73, comma 8 over square root 73. There we go. Alright, and let's get one more example just to kind of get used to the process. So right here we have 12 square root 2 and -8 square root 12. So we'll go ahead and find the vector, and that is going to be 12 square root 2 squared plus -8 square root 12 squared. This will give us 12 squared is 144 times 4. Oh, sorry, 2. Don't want to change that. Plus -8 squared is 64 times 12. Alright, so then we get v equals square root, sorry that, there we go, of 288 plus 64 times 12 is 768. Add those two together and we get 1056. I don't think that's a perfect square. I'm pretty sure it's not. Yeah, no. So we're going to find the biggest perfect square we can think of. Let's go ahead and try 4. Feels very possible. Yeah, 4 works. Let's try 16. Perfect, 16 works, and we get square root 16 times square root 66. 66 is just 11 times 6, which is just 3 times 2 times 11, so there's no perfect squares left in here. Square root of 16 is going to be 4. So 4 square root 66. We'll rewrite our value then as 12 root 2 over 4 root 66, comma, negative 8 root 12 divided by 4 root 66. Again, we're going to go ahead and reduce 12 and 4, they divide into 3. 2 goes into 66 33 times, so it's going to be 3 over square root 33. And then, you may also notice I'm going into another problem. So when I go over this problem, you'll see some of these things, no big deal. Now, on the other one, the other value, we will have negative 8 divided by 4 is going to be negative 2. Now, they both share 6, so that's going to reduce this guy to 11, and that's going to reduce this guy to a 2. So negative 2 square root 2 over the 2, just square root 11. And that will be the vector, unit vector here.